The next step in the DD2 nuclear power facility involves building a whole bunch of iron and steel and related things. Now, there's been a bit of a delay. I thought I had solid power or solid water. Thought it was nice and reliable and robust. But these top two lines, all too often when I'd enter the game, they would be low capacity. Or if I turned on a bunch of things, they would be low capacity. It turned out I had a few things going wrong in my water. Let me show you what that is really quick. We'll get the water issue out of the way before we swing into doing a build. So the big one, I don't even have to show you in the blueprint. All those water extractors over there, they're all supposed to be running at a 250% overclock. So each pair will feed together to produce 600 cubic meters per minute of water. And it turns out that a good number of them had the power shards installed, but hadn't had the slider slid. And a number of them, not quite as big, didn't even have the power shards. So fixing that up helped some, but I still had a problem where things were pulsing. Things would run okay for a bit, and then they would dump. And then they'd run okay for a bit, and they would dump. Yeah, by dump, I mean the quantity of water available would slack off. And I finally realized that it was because of the way I was bringing my, that's not the one. It was the way I was routing my pipes. Let's see if I can find it. I have new pipe stuff going, which I just showed. Load blueprint. Did it get put away? I may have just wiped out the blueprint. I don't know. Do a quick check for it here. I should have located this before I started. Anyway, it's probably gone. But what I had, if I can clear the designer here, was a situation where the pressurized pipe coming down from the top of the water tower ran along the set of extractors here at ground level. The extractors then came together at a X junction above that, so it was pressurizing it from below with water from the water tower, and then the output went up, and that seemed to work. And of course, if I have all of these and I start tapping a few pipes randomly, it still works, because here's the problem. Satisfactory, given multiple sources of water coming into a pipeline junction, will drain the low ones first, take from the low ones first. It's the whole variable input priority scheme thing. Let me bring up the one I'm actually using. So when I realized this, the problem is that with the way the priority was set, it was prioritizing taking from the water coming down from the top of the water tower. So if we started consuming that, if you consume enough, you can dry the pipe out and you no longer have the head lift. So after you run for a while, suddenly nobody could have head lift. So then you'd be running on whatever water you had until the head lift was reestablished. So I have fixed up the water. I've made it so that we do have 600 cubic meters per minute being pumped to the top of the water tower and back down. So that will help us if we start to run into that condition. But more importantly, I'm now using this mechanism. I don't know why that keeps coming up as black. Basically, what we've got here, to get my pipes out. This is the blueprint that I dropped down between the extractors. So I'll have one extractor over here and one extractor over here. And we are the bottom layer, so whatever we do, it's going to preferentially take from the bottom layer. It will flow from the bottom layer. And then we have a Mark I pipe on both sides. It's actually level. And this is my pressure pipe. This came down from above. So we will only take from the pressurized pipe if these guys are not full. And then we distribute out the top. Boom. And I'll go on upward. I was worried that maybe it would be a little weird. I thought I might have to tap the pressure line and bring it in one place and then someplace else. So I might have an X. I got a number of complicated things I thought about, but I put this in place and thought, if this works, it'll be great. And it turns out it does seem to work. We'll find out. If it doesn't work, I can always go back and fix all 42 of them. But when I got it all set up and started it going, it filled up these horizontal pipes very quickly instead of very slowly, which was really good. I think the fact that it was filling up these pipes was enough to drain water out of the water tower and reduce the head lift. So now we are running with our copper and our concrete and our rubber, and I'm just leaving these running full tilt. So our next step here, if I can swing into the real build, this is a big one. This is iron and steel and a whole bunch of things that are made with iron and steel, and it's all kind of compact and tight because there's some high volume flows in it. For ease of building, I'm breaking it up into smaller pieces. So I think I can show my editor. There we go. So here's the first of the sections. There's actually, I think, 5 of these build steps that I'm going to do. And I have to do this 4 wide, so I wanted to break it down into bite-sized chunks and then say, well, I'll do this and then do it again 3 more times. That means I can use a blueprint for it. So the first one is Pure Iron Ingots. It's the same blueprint as the Pure Copper Ingot, and the only difference will be the recipe and the fact that it is overclocked at 225% rather than 200%. That's easy enough to fix up. The other thing that I did recently that didn't mention, when I put all of my resource gathering in place, I only had 6 drone ports providing iron, which is enough iron total, but if I'm going to be doing these as 4 groups of whatever, I want it divisible by 4. So I now have 8 drone ports out there that can send me iron. And that's all tested and working. So let's start off with placing the same old Pure Copper Ingots blueprint down. And change the recipe on that. This would take a lot longer if I had to do this manually. We want Pure Iron Ingots, and I am going to run it at, I think I'm going to go ahead and run it at 250. So we are going to overproduce iron ingots. I am fairly sure that I have more than enough iron ore to do it, but what if we multiply all this out? So 12 of these by 50 is 600, so running at 250, we can still fit all 12 of these on the water. What I will do is this by 3 is 87.5 times 3 is 262.5. We can certainly have 2 drone ports feeding 1 drone port, getting 262.5 iron ore. So those are all feasible. iron ingot output is going to be 162 by 3 is a bit over 480, so that'll fit on one belt. So I'll end up with 4 mostly full belts of iron ingots, and we can always split and merge that as necessary depending on how it gets used. So there is my recipe and my configuration. Okay. So I want to work from the input to the output. So we'll tend to saturate things. And the first thing I want to do is get the water set up. Now these guys are all going to share one 600 unit water pipe. So we're going to be coming in from over here, which means I need to activate the next water pipe down. And it's going to have to come in on the left. So what I'm going to do is I'm going to use this top water pipe for my new one, and the middle pipe, oh, thank you, autosave. The existing pipe on the left here, which will become the middle pipe, is going to be using the middle pipe from this group of 3. And I want to get rid of, well, maybe I could do it without getting rid of that. So I put that there, I put that, oh, nope, that's the wrong place. Need to line it up like that and set it to 1, 2 over from there. And that's going to be the bottom one. Just like that. So there, he's hooked up to the next one in line, which is, it had a bit of a burst there as it had to make up for lost time, and it's going to catch up very shortly. The top one needs to be over here. And I want to put it in here where it's nice and squared off. And these are all, there we go. And now we can remove the supports. I want that to be no indicator, but as I extend it, it will prefer to change it rather than add it to it. So we'll do that first. And now we'll change this to no indicator. That. I still don't like these horizontal lines, stretch marks on the pipe, I think they are. Okay, now we need to run this down to meet up with our target, and I like to put in a support on every one of these transitions from one deck to another. I like to do things, with 90-degree bends, but that looks kind of cool. So that should fill up all these water things fairly quickly once I get power going. So now we get power. Now what I've been doing here is setting up power on these power switches like this. So now we need to place a power switch for us. The other thing I've been doing is, instead of leaving it floating or leaving one of these in place, I've been putting a minimum size wall. So it looks like there's like a railing or something that the power is sitting on. And we can actually put the power pole right like that. So if I start worrying about making my factories look like they've got support, that's fine. And this power plant, or this power switch, is going to be called DD2E, oops, Iron Refinery. I keep putting outpost in quotes for these because these outposts are all very tightly clustered within belt range of each other. So they are outpost designs, but they're not using outpost logistics to move stuff between them. And so we potentially had 360 megawatts feeding these machines, and I've hooked it up, and we are getting good power. We're getting 137 gigawatts of power coming in. That's a 90 gigawatt nuclear power plant, plus up to 43 gigawatts from oil, and so things fluctuate a little bit. Not exactly sure why, they just do. So all of these guys are now running. They've got water coming in, and now they need their ore. So we pick up the drone port that I designed recently. And this has the batteries that, from the way we're looking, move from right to left. Or my original port had them going the other way. So the batteries will hook up. And I've got some. Yeah, at this level, I'm only going 2 of these guys, so I can actually put these in manually from here. I don't really need to use a blueprint. Except I think, yeah, I put it at the wrong level. Start from here. That's better. Okay, so now we've got 4 drone ports that we need to set up with power and batteries and give them a name and program them, and that'll call in resources. So first off, I'm going to run the batteries so that the lines will be full of batteries and ready to start supplying. The power, I've been trying to keep the power for these tucked away underneath. So it'll go from here, it'll go down, and then out to a common place. This means I won't have power going across this open area here. I'll be able to see the batteries, but the power will be hidden away nice and tucked underneath. And I put it 1.5 foundations in. Make sure I put it in the right place. I think it's, yeah, it's here. Is that right? Here. Oops, wrong place. Well, we can fix that easily enough. We can grab from here. And we can stretch it out to the right place. Delete that and hook this up. Okay, so these guys now all have power, and they've got batteries coming in. So the way I'm doing this, just to review, is this is the requesting station, so I have batteries here, and the drones live at the producing station, so I got multiple producers sending their drones to the consumers. And I only have to have batteries at the consumers because there's fewer consumer stations, so it's easier to do that bit of work. So, all ports has iron ore. So we see DD2E has iron ore. I have 8 of these guys. So we are called DD2A wants iron ore. And I'm just going to put that string in on them all, and it'll automatically put a number after it. If I called the first one wants iron ore 1, the second one would be called wants iron ore 1-2, and the next one would be wants iron ore 1-3, and that's no good. So we do that, and then I can go back to the first one and add a 1 to the name. Now, go to all ports. We do that search for has iron ore again, and I'm going to put number 1 and number 5 on this port. So I'm kind of going to balance them across. This gets number 2 and number 6. This one gets number 3 and number 7. And this one gets number 4 and number 8. And interestingly enough, this list, if you get too many on them, like if I said just DD2, it says there's 60 ports, and I'm throwing the 13 farthest. Why can't I scroll this list? Anyway, so with that in place, we're going to start getting our iron ore coming in. And now we need to take the iron ore from here and move it across back to this third row and feed it into these belt lines. And the level is going to be raised above this copper. So I need to figure out how high it has to go here. We're going to go vertical. And I'm just going to poke it in right here. So with 8, this is the height that I would get to put the belt in there. I think I can go 10, as long as I don't try to do anything fancy. With 10, the merger will show up here. I think that's the level at which you would do this. So there's how high we want it to be. We will need a belt support here and here and here, and then routing back that way. Got it. And over on this side, come on, fumbling a little bit here. So this is the copper coming down from the one below us. So our route is going to come down 4 in from here, like, yeah, right up against the edge, just like that. And let's make sure we have room here. Yes. So there's where we're going to come down. And now we put them all in place. Make sure those line up. Yep, they're all put in the same place relative to their port, and that's the wrong way. Let's finish up with the belts up above, and we'll be done with things up on this particular deck. Next deck down, we just need to drop it down vertically. The easiest way to do that is to grab this and just floop it down like that. Just ignore the fact that I'm wasting some resources. And it goes there. And for the others, I can just count it over. 1, 2, 3, 4. 1, 2, 3, 4. That one's already there. 1, 2, 3, 4. Now, if I got them misplaced, then these won't clip in. They're clipping in, so we're good. And you can see we already have ore on these lines. So I brought that down by 2 ticks. I am going to stripe this out this way and establish our level. And we go out to here, and we're going to be on the right-hand side of this. Although I think instead of running my high plates this way, I'm just going to use this one to give me my level and just run out this way. And now we can remove this. It's a little finicky because I'm way too close to the refinery. But now I have the places where I'm going to establish my supports, and I can put in my up holes. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. We're going to accept our inputs from the right. Normally I wouldn't delete this panel, but I'm pretty sure I got everything in the right place. If not, then you'll see me rebuilding it. It should come down 1, 2 ticks, I think. Yeah, 2 ticks. Okay, so now we go pick up our actual ore coming in. We put our supports in on every deck area. A deck is what I'm calling 4 foundations by 4 foundations, which is the size you can lay out with the blueprint machine. Two ticks and in. And this guy, we're just feeding it the other direction. I'm actually not leaving any explicit space between the blueprints here because the refinery groups here are not quite filling the deck area. So they've got a little bit of space left and right, and the front porch is kind of wide enough to have some water maneuvering and some raw materials maneuvering. The back porch was fairly shy. And we do need our awesome sinks. Because until we actually start using this stuff, I want to have this set up to just exercise the heck out of it. So we don't get a nasty surprise the first time we crank everything up. Oop, one more. Thank you, autosave. So by placing the lifter at the bottom first and setting it to go top to bottom, I can then rotate the top into place, tight into the merger like that, rather than having it stand way off. I like the look better. But you do have to make sure to line up the bottom where you want it first and then rotate the top into place. Come on, 4. So we rotate that and take that in. Now, in theory, we've got everything hooked up, except we don't, because I didn't actually hook up the last 2 lines yet. See, if I don't stay focused and do everything in order, I make mistakes like that. And this. Yeah, so I've totally forgot. Oh, there it is. So I just didn't have it at this end. Put a bink and in. Did I see a vertical back there that was unhooked? No, it was hooked up. It was just sunk underneath my panel. Snake these out without deleting the refinery. This ore is not moving. Our outputs are full. Our sinks don't have power yet. So we're just going to hook that into our existing power poles. So if I've done everything right, these should all 12 stabilize at running flat out with all of the ingots getting to the sink, and all of our inputs hitting on all 4s, just working. So this is the water we're taking from now. This is the new pipe that we tapped to take over for the old one. So we've got water, we're full, and the flow rate is kind of fluctuating. That's what makes me wonder if I should put in some fluid buffers. But that's the rubber. Remember, that's the one where I've got 600 water available. I am only using 240 of it from that pipe. But the iron processing needed a whole pipe to itself, so we just gave it the next one. So these guys are steady state now. And this says it was at 0 for a while, so it'll take a while to ramp up, even though we can see that it's got all the input it wants. So I'm going to pause. Yeah, it looks like the iron and steel area is going to take a number of recordings. So what I'll do is I will cut forward to evaluating the performance of this after it has run for about 10 minutes. Okay, back for the performance evaluation. You can see that I have basically taken all of the outputs from this row and now striped them across on a vertical bus coming out here at the end. So we've got our concrete and our rubber and 4 belts of iron ore, or iron ingots. So it's really only needed for us to check the last one of each group of 3. And if it's showing 100%, we're good. And remember, these are tuned up from the required numbers. So 162.5 is, let's see, come on. That's 1,950 iron ore. And what we really need is 433.262 times 4 is 1733. So we've got a modest margin. So if there are manifolds downstream, we will fill them fairly well, fairly promptly. If you have exact inputs, exact outputs matching, you can end up taking a very long time to get the manifold going, because every piece of input, every item sitting in the manifold is something that wasn't used yet. So you take how much ever fills the manifold and you divide that by your input rate, and you use that. You can use that to figure out, well, how long will it be until I actually have output? And the problem is you're going to start ramping up your output slowly from the beginning. So it's not that you're going to skip the first n items, it's that you're going to skip n items over an extended period of time. I think I have to write some Python to work that out. On the other hand, if you got your manifold set up with a smart splitter, then it's a little more predictable. It's a little more easy to watch as it fills up the first machine, and the second machine takes longer, and the third machine takes longer. And you get to where the last machine is just getting it's getting everything that it needs, but not quite. So better to have a little bit of extra where you can, within reason. And all of this is getting hit into these. I just peeled off 11 more coupons, by the way. Our big spikes here are when we are recycling the plutonium rods from our other nuclear power plant. Those are just huge in terms of points. So this power plant is going to be recycling twice as many rods. So our number of coupons are going to go, our coupon rate's going to about triple. So that's the iron refining part of our iron and steel area. This is part 1 of 5 on this. I will go plan the next parts and get those recordings going shortly.